me give an overview over here. So suppose we have some CH3Br plus NaOH, sodium hydroxide. So nucleophilic substitution reaction. If I say nucleophilic substitution, so nucleophile is something which has a electron, which is electron rich. Nucleophile क्या होता है? They are electron rich. Nucleus loving. Nucleophile means nucleus and philic means loving. Nucleus loving होते हैं and they are electron rich. They are electron rich. So nucleophilic substitution reaction. So in the nucleophilic substitution reaction, there are two components. First one is your substrate, and because we are just talking about the haloalkanes here, so the substrate क्या होते हैं? Haloalkane. Okay, haloalkane or alkyl halide, you can say, is the substrate over here. So, and the nucleophile is the negatively charged species, which is an electron rich. So, suppose we have this reaction CH3Br, CH3Br. So, we are just talking about the SN2 mechanism. SN2, just remember SN2, nucleophilic substitution reaction, which is bimolecular. 2 यहाँ पे क्या denote करते हैं? It's a bimolecular. Molecularity and order is 2. Okay, so here the rate of reaction depends on both. Okay, means इस पे भी depend करेगा on the substrate as well as on the nucleophile both. So what happens in this case? NaOH, when you are taking NaOH, so it will dissociate to form Na plus and OH minus. OH minus. So what is nucleophile in this? OH minus, because this is electron rich. So what happens over here? OH minus, it will this reaction, nucleophilic substitution reaction, SN2 reaction, occurs in a single step. Single step में होता है. Means attack of nucleophile. Again, this is your alkyl halide, right? So bromine is electronegative, so this will acquire partial negative charge, and this carbon of the alkyl group will acquire partial positive charge. Okay, now this is electron, this nucleophile is the electron rich, तो ये किसे attack करेगा? Positive charge for obviously this carbon. So once it attacks this CH3 group, so this bromine, which is electronegative and is a good leaving group, it will left them. Okay, means the attack of nucleophile and the leaving of the leaving group. Okay, the cleavage of this CH-Br bond will takes place in a single step. Okay, so what happens? यहाँ पे substitution होता है, bromine यहाँ पे bromine को कौन replace करेगा? OH group, and you will get CH3OH. CH3OH and NaBr will be formed. So that is the nucleophilic substitution reaction 2. Okay, bimolecular nucleophilic substitution reaction. Clear, Hossein and Lubna?
Yes, ma'am.
Okay, so just I gave you the overview. Please just go through the recording, then you will get to know what are these reactions. Okay, so reactivity of SN2 mechanism. So since SN2 occurs via backside attack, okay, SN2 जो होता है हमारा bimolecular nucleophilic substitution reaction, it occurs via backside attack of nucleophile. So there are two ways by which nucleophile can attack, either from the front side or from the back side. So in SN2 में क्या होता है? The nucleophile will come and attack from the back side. So backside attack से होता है. So the reactivity towards SN2 depends on the ease of attack of nucleophile. जितनी easily attack कर पाता है nucleophile, so the reactivity depends on that. So the rate of nucleophilic substitution reaction SN2 is inversely proportional to the number of bulky group on the alpha carbon. Rate of bimolecular nucleophilic substitution reaction is inversely proportional to the number of bulky group. More the number of bulky group on the alpha carbon, the less will be the reactivity. Slow will be the reactivity. Okay, so suppose we have these 4 compounds. CH3X. Okay, so here only one alpha carbon is present. Okay, so here alpha carbon पे क्या present है? Suppose you can just draw the structure. This is the carbon. Halogen atom is attached to this carbon, so this is the alpha carbon. And 3 hydrogen are present. So hydrogen is not a bulky group. So here the bulky group is not present. So its reactivity will be quite high. It बहुत ज़्यादा reactive होगा towards SN2. Now see this. So here On this carbon, alpha carbon pe only one CH3 group is attached, and CH3 is a bulky group. One CH3 group is present. Okay, so its reactivity will be less as compared to this. Okay, next is यहाँ पे देखो halogen atom is attached to this carbon, so this is the alpha carbon, and there are two methyl group, CH3 group and 2CH3. तो here 2CH3 group है, यहाँ पे क्या है 3CH2 group. Okay, आप ऐसे भी decide कर सकते हो, and you can also decide it by a 3 degree carbocation or 2 degree carbocation or the 1 degree carbocation. Okay, or halogen halide भी आप कह सकते हो, not carbocation, because this is SN2 mechanism doesn't require a carbocation. Okay, it occurs via a single step and by a transition state. Okay, it basically involves a transition stage. So we will not talk about the carbocation over here. So this is a tertiary alkyl halide. Okay, tertiary alkyl halide mein you can see there are three bulky groups. So the X halogen atom is attached to this carbon. So this is the alpha carbon, right? And alpha carbon se kitne groups attached hai? How many methyl groups? Three methyl groups. 1, 2, 3. CH3. This is again CH3 and this is the CH. Three methyl groups. And methyl groups are bulky. More the methyl group or more the bulky group present, which is attached to the alpha carbon, less will be the reactivity. Less will be the reactivity. सबसे least reactivity किसकी होगी? इसकी. After that, this one, because in this compound there are two bulky groups present, which is attached to the alpha carbon. After this one and this. There. Yes, Ali, Qudsiyan, Lubna, clear, बच्चों?
Yes, ma'am.
Yeah, one more point you should remember. Alpha unsaturation. Alpha, if there is a unsaturation, means the double bond or the triple bond present on the alpha carbon, alpha position. So it will decrease the rate of nucleophilic substitution reaction. It will decrease the rate of nucleophilic substitution reaction. So you can see, if I give you, if I tell you to compare the reactivity between these two, so this will be more reactive. This will be more reactive towards the nucleophilic substitution reaction. Why? Because in this case, you can see the chlorine is attached to this carbon. So this is an alpha carbon. And this alpha or beta carbon, this is beta carbon, which is adjacent to the alpha carbon. In दोनों के बीच में, you can see there is an unsaturation, double bond. Okay, double bond is present. So if the double bond or the triple bond means the unsaturation is present on the alpha carbon, so it will decrease the rate of nucleophilic substitution reaction. So that's why in these two compounds, so the reactivity of this will be more as compared to this. Similarly, this one, you can see bromine is attached to this carbon, and this is your alpha carbon. So alpha carbon पे unsaturation is present. So this will be least reactive as compared to this. So this is more reactive because there is no unsaturation in this compound, in the alpha carbon. Okay, we will talk about the alpha carbon. If suppose, between like this one, bromine, and यहाँ पे alpha saturation है, and here this bromine, and this is, yeah. Now tell me, in these two, which is more reactive towards the SM, nucleophilic substitution reaction, between these molecules? Suppose this is a A and this is a B. Which one will be more reactive? Anyone? Ali?
B.
Why B, Ali?
Because there is no unsaturation at alpha and beta.
Yes, very good. Right? Because alpha, there is no unsaturation between alpha and beta. So you have to check which one is your alpha carbon. So if there is a unsaturation between alpha and beta carbon, alpha and beta position के बीच में, if there is an unsaturation, then it will decrease the rate of nucleophilic substitution reaction. Okay, so that's why this B will be more reactive towards nucleophilic substitution reaction, because suppose this is your alpha. Bromine is attached to this carbon, so this is your alpha, and this is your beta. There are two beta positions, and again this is a beta. And in both the beta, between this alpha and beta 1, suppose this is a beta 1 and this is a beta 2, there is no unsaturation. So the rate of reactivity will be fast in this. Okay, but here when you check this compound, so this is the alpha position and this is the beta. And between the alpha and beta, there is an unsaturation. So that's why this unsaturation is decrease the rate of nucleophilic reaction. Now, in SN1, in nucleophilic unimolecular nucleophilic substitution reaction, the carbocation formed is unstable. The carbocation which is formed is unstable due to the presence of more electronegative sp2 carbon. Due to the presence of more electronegative sp2 carbon adjacent to carbocation. This is quite interesting. Now, see what I said. So here, so in SN1 की बात हो रही है unimolecular. So know very well unimolecular में क्या होता है? It's a two-step mechanism which follows the carbocation formation. Okay, in the first step there will be a formation of carbocation or the cleavage of your Rx bond, and in the second step there will be attack of nucleophile. So in this, in the SN1 में क्या होता है? The carbocation which is formed is unstable due to the presence of more electronegative sp2 hybridized carbon. sp2 hybridized carbon, which is adjacent to the carbocation. So suppose, let's take example. Suppose we have CH2 double bond CH and this is your X. Okay, and you know very well between this carbon. Suppose this is your halogen atom is attached to this carbon. So this you know very well the halogen is more electronegative than the carbon. So it will try to uh, pull the electron density towards itself. So यहाँ से क्या होगा? The bond will be break. Bond will be break. It will leave the group, and due to that there will be a CH2 double bond and CH. And CH पे क्या आ जाएगा? When that bond will break, so there will be a positive charge on this. Means the carbocation is formed. Carbocation is formed. Now, what happens over here? You can see the carbocation is formed here on this carbon. ये क्या है? Carbocation. But there is a double bond over here. Okay, and you know double bond basically basically this carbon is sp2 hybridized carbon. So the adjacent carbocation ये है, and the carbocation के जो adjacent जो carbon है इसके hybridization क्या है? sp2. And sp2 hybridized carbon is electronegative in nature. It is more electronegative than the sp3 hybridized carbon, right? So ये तो positive है, but this is electronegative. This sp2, this is the sp2 hybridized carbon. So what it will, because it's electronegative, तो ये क्या करेगा? Electron density को towards itself. It will try to pull the electron density towards itself. This CH2, because it's a sp2, and sp2 क्या होता है? They are more electronegative. So if they are more electronegative, they just try to pull the electron density towards itself. Okay, and what happens due to that? The carbocation which is formed is unstable. Okay, due to the presence of sp2 hybridized carbon adjacent to this carbocation, the whole molecule is become unstable. The carbocation formed in the SN1 mechanism is unstable. Got my point? Why the carbocation is unstable?
Yes, ma'am.
Lubna and Ali, if it is not clear, just ask me. Okay. So, due to the presence of sp2 hybridized carbon, which is more electronegative, so this carbocation, which is formed in the SN1 mechanism, is unstable. Okay, when you will see this type of arrangement, when the halogen atom is directly attached to the sp2 hybridized carbon. Okay, when you see this type of arrangement, so in this, the SN1 mechanism is quite unstable and it is quite not possible. Why? Because the carbocation formed is unstable due to the presence of more electronegative sp2 hybridized carbon adjacent to the carbocation, which makes the carbocation unstable. Next is, suppose in the SN2, now we are talking about the SN2. SN2 में क्या होता है? The nucleophile is repelled by the electron-rich pi bond and it does not attack. Now, in the same molecule, suppose this is your molecule. Okay, if there is unsaturation. Okay, this is the case when there is an unsaturation on the alpha carbon between the alpha and beta carbon. So if there is unsaturation between the alpha and beta carbon, it will decrease the rate of nucleophilic substitution reaction. In the SN1 reaction, the carbocation which is formed is unstable due to the presence of more electronegative sp2 hybridized carbon. But in the case of SN2 mechanism, what happens? See, this is a chlorine, right? So what happens? Because यहाँ पे कोई भी in SN2 there will be no formation of carbocation. So it will occurs in a single step. First, in single step, there will be a attack of nucleophile and the cleavage of this bond, right? So what happens? Because this is a more electronegative, this sp2, this sp2 hybridized carbon, this is sp2 hybridized carbon, and sp2 hybridized carbon is more electronegative than the sp3. So when the nucleophile will come, when the nucleophile in the SN2 mechanism, nucleophile, because nucleophile again is a rich electron rich hai, and this carbon is again electron rich because it's a sp2 hybridized carbon. sp2 hybridized kya hote hain? They are electronegative. Okay, so what happens when the nucleophile which is having a negative sign, so when it try to approach this carbon, this sp2 hybridized carbon, it will feel repulsion. यहाँ पे repulsion होगा. Okay, it will feel repulsion. Okay, so it does not attack the pi bond, electron rich pi bond. So this is sp2 hybridized carbon and this is again electron rich. And when the electron rich nucleophile come and try to approach this carbon, so there it will feel the repulsion. यहाँ पे repulsion feel होगा and this nucleophile will not be able to attack this carbon. Clear to everyone?
Yes, ma'am.
Okay. Next is the nature of living group. Next topic is the nature of living group. Now the living group here is a halogen atom. So the nature of living group, the living group in nucleophilic substitution reaction should be able to bear negative charge. Living group ऐसा होना चाहिए which should be able to bear a negative charge. So hence, the larger the size of the living group, faster is the reaction. Faster will be the reaction. And tell me, when you move from top to bottom in a group like fluorine, chlorine, bromine, iodine, we are just talking about the group 17 elements. So when we move from top to bottom in a group, what will be the change in the size? The atomic size will increase or decrease from top to bottom. Increase or decrease? Sia? From top to
Increase.
bottom, the size will increase. Yes, good. So the size will, atomic size क्या होती है? Atomic size will increase. Increase होगी when you move from top to bottom. So iodine will have is having the larger size, okay, and the fluorine ki smaller size, okay, as compared to all this, right? So it means the larger the size of living group. So living group यहाँ पे क्या है? We are talking about the haloalkene. So here the living group is a halogen, which is electronegative element. So the living group in the nucleophilic substitution reaction should be able to bear negative charge. And the larger the size of the living group, faster is the reaction. Means when you take iodine, the reaction will be fast as compared to the fluorine. Okay, So the rate of nucleophilic substitution reaction is directly proportional to the size of living group. The size of living group. So this is the order. Ri का size क्या होगा? सबसे ज़्यादा होगा. Okay, Ri, your alkyl iodide will have the larger size as compared to the alkyl bromide, alkyl chloride, alkyl fluoride. So that's the order of the size of the living group or the rate of nucleophilic substitution reaction. So it's very clear. The size depends on the size of the living, and size किसका ज़्यादा होता है? Iodine. Okay, so here's the question. Out of these two molecules, CH3 whole thrice C bromine over here, this is A molecule and this. Okay, so the alkyl group is same in both these. Alkyl group is same. But the living group means the halogen is different. Here is the bromine and here the iodine is attached. Now the question is which one is more reactive towards SN1 and why? Very simple. It's very simple. You can see iodine. Iodine यहाँ पे लगा means iodine has a larger size. Okay, so due to the larger size, iodine is larger in size, so it is very easy to break the bond. CI bond को break करने में काफी easy होगा because there will be a less force of attraction between the carbon and iodine. Due to the large size of the iodine, there will be a less force of attraction, and जितना less होगा force of attraction between this carbon and iodine, the the cleavage of the bond or the breaking of bond is quite easy for us. Okay, so it depends on the size of the living group. So iodine is larger in size, so it is quite easy to break the Ci bond than the CBr bond. So that's why this B molecule is more reactive towards nucleophilic substitution reaction, SN1 reaction. Clear?
Yes, ma'am.
Okay, next. Nature of solvent. Nature of solvent. So, nature of solvent में there are two types of solvent. Polar protic solvent, polar protic solvent, and the second is your polar aprotic. Now, what is polar protic solvent? So, polar protic solvent means there will be polar क्यों होता है? What does this polar means? Polar comes when there is a electronegativity difference between the atoms. दोनों के बीच में electronegativity difference होगा, then the polarity comes. So it should be polar, and the protic means there will be a proton. H plus ion होना चाहिए. So polar protic solvents. So hydrogen present होना चाहिए, protons present होने चाहिए, and it should be polar. So those type of solvents which are polar and they have protons, so they are known as polar protic solvents. So due to the polar protic solvent, it increases the rate of nucleophilic SN1 reaction and hinders the reactivity of SN2 reaction. Okay, you should remember this. So due to the polar protic solvent क्या करता है? It increases the rate of SN1 reaction, unimolecular nucleophilic substitution, and it hinders the reactivity of SN2 reaction. Right? And the best example of polar protic solvent is water. It's water. You can see यहाँ पे क्या है? There is a between H2O. You can see there is electronegativity difference. Due to the electronegativity difference, there will be a polarity. There will be a difference in the electronegativity. There will be a dipole moment, right? So everything depends on the polarity and the difference in the electronegativity. So it's a polar. यहाँ पे polarity है, and here the proton is present. Okay, H plus ion is present, proton is present, so it's a polar protic solvent. So what is the best example? Again, another example, methanol, ethanol, etc. Okay, so these are polar protic solvent. So due to the polar protic solvent, if you are taking the polar protic solvent as a in your reaction, so it will increase the rate of unimolecular nucleophilic substitution reaction, but it will hinder the reactivity of nucleophilic substitution reaction by molecular SN2 mechanism. SN2 reaction को वो hinder करता है. Okay, so PPS means the polar protic solvent is used in SN1 reaction to increase the rate of nucleophilic substitution reaction. But polar aprotic solvent आप किसमें लेते हो? SN2 mechanism. Okay, so polar aprotic solvent. Aprotic means A means the absent. Polar hoga. It should be polar means the polarity hogi वहाँ पे. There will be a electronegativity difference, but the proton will be absent. Okay, but the proton नहीं होगा. Proton should be absent. Just like a acetone. Acetone. Okay, acetone होता है CH3 CO. Okay, so acetone, in the acetone, it's a aprotic solvent, DMSO, right? So it's a structure, SOCH3, this SOCH3, SOCH2. So these are some polar aprotic solvent. Polar aprotic solvent. So polar aprotic solvent, it increase the rate of reaction of SN2 reaction. SN2 reaction में we use the polar aprotic solvent, but we use polar protic solvent in the SN1 reaction to increase the rate of reaction. Clear to everyone?
Yes.
Yes.
Yeah. So here's the remarks over here. So polar protic solvent increase the rate of SN1 reaction by stabilizing the carbocation. ये क्या करता है? It will stabilize the carbocation. Carbocation को stable बनाता है. This polar protic solvent. So that's why we just use a polar protic solvent in the SN1 reaction to stabilize the carbocation. More the stability of the carbocation, more will be the rate of reaction. Okay, the easy will be the more the reactive will be the carbon. Polar protic solvent hinders SN2 reaction as the solvent is also electron rich and it can attack on ions. Right? Why it hinders? Because solvent में क्या है? Protic है. It's a protic and the polar. So solvent is again the electron rich and the SN2 mechanism, in the SN2 mechanism, this RX, you just take it's a one step mechanism, right? So there will be no formation of carbocation. So first step में ही reaction हो रहा है and the nucleophile will come and attack this R group, alkyl group, okay, which is electropositive. But what happens when you use the polar protic solvent in the SN2 reaction? So polar protic solvent is again the electron rich. So ये क्या करेगा? Because nucleophile ना attack करके polar protic solvent can attack the RX. Okay, and here the nucleophilic substitution reaction will not occur because instead of nucleophile, this solvent, polar protic solvent will attack this R group because this polar protic solvent is again the electron rich. Okay, so that's why it will hinder when you use the polar protic solvent in the SN2 reaction. What happens? It will hinder the attack of nucleophile. वो न्यूक्लियोफाइल को अटैक नहीं करने देता, वो खुद अटैक कर देता है your substrate. So that's why we don't use a polar protic solvent in the SN2, but we use the we use a polar protic solvent in the SN1 reaction to increase the rate of reaction by stabilizing the carbon. Clear? Any doubt, anyone? Qudsiya, Lubnan, Ali?
No.
Now, the reaction with KCN and EGCN. So I have already discussed it yesterday, like what is ambidentate nucleophile and in the potassium, when there is, I just remember one thing, when the potassium, cyanide is attached to the potassium, okay, potassium के साथ है, तो the, because this cyanide is basically ambidentate nucleophile. So you were not there in the previous class, so let me uh, explain what is ambidentate nucleophile. So ambidentate nucleophile is the nucleophile which has more than one attacking site. Okay, जिसके पास एक से ज्यादा attacking site होता है, donor site होता है, that is the ambidentate nucleophile. I think I have mentioned it over here. Somewhere I have written the definition, you can write on. Yeah. This is the definition of the ambidentate nucleophile. If you want to write, you can. What is ambidentate nucleophile? So those nucleophiles which have more than one donor site or nucleophilic center for the attacking and the bond formation is the ambidentate nucleophile. Suppose cyanide, CN. So cyanide, in this cyanide, it can attack from the carbon side also, and it can also attack from the nitrogen side. So just you have to remember that when the KCN, if you have given the KCN as a nucleophile, so here when the cyanide is with the potassium, cyanide is attached to potassium, so just remember in this case the attack will be from the carbon side. Carbon की तरफ से attack होगा. Okay, and if it is with AgCN, silver cyanide, so here the attack will be from the nitrogen side, and in this case it will form isocyanide. Nitrogen के side से होगा तो it will form isocyanide, and when the attack is from the carbon side, so it will form the cyanide. It will form the cyanide. So that's the ambidentate nucleophile. It can one nucleophile can attack from more than one site. Okay, so nucleophilic center or the donor site is more than one. NO2 is again the ambidentate nucleophile. It can attack from the oxygen side or the nitrogen side also. AgNO2, okay, AgNO2 हो गया आपका, your KCN हो गया, your AgCN हो गया, KNO2 is another nucleophile, ambidentate nucleophile. Okay, so we will see that this question is again very important. This question is again very important. Just I have seen that many times in the previous year questions. They just ask you reaction with KCN and AgCN. Okay, so in these two cases, you will get different product. So suppose the first reaction is reaction with KCN, potassium cyanide and silver cyanide. So first case is reaction with KCN or NaCN. Potassium की जगह पे आप sodium cyanide भी ले सकते हो, cesium cyanide भी ले सकते हो. So in all the cases, when you take the cesium cyanide or sodium cyanide or potassium cyanide, the product will be the CN. Okay, means attack will be from the carbon side, not from the nitrogen side. You have to attack the nucleophile will attack the substrate, means the alkyl halide, from the carbon side, not from the nitrogen side. Okay, so just keep this in your mind. Clear? Just keep this in your mind. Okay, so let's see. When alkyl halide is treated with KCN, they form alkyl cyanide, which is also known as alkyl nitride. जिसे हम alkyl nitride भी बोलते हैं. For example, this is the basic reaction. General reaction RX. RX क्या है आपका substrate. RX is your substrate. Substrate means here it's a RX here is a alkyl halide, and you are taking KCN. So in this KCN, potassium cyanide, this bond is ionic. This potassium and CN bond is ionic in nature. So it will dissociate to form K plus and CN minus. So you have to remember, अगर cyanide potassium के साथ attached है और sodium और cesium के साथ attached है, so it will form ionic bond. It is ionic in nature. If it is ionic in nature, so it will dissociate to form K plus and Cn minus, which I have written over here. K plus and Cn minus. Now the Cn minus is a nucleophile over here. Now in this case, the nucleophile will attack. This nucleophile will attack from the carbon site, not from the nitrogen. So what happens? यहाँ से attack होगा and this will attack this alkyl group, and यहाँ से it will left the group, and you will get RCN plus KX. RCN alkyl halide, which is substituted. X will be substituted by your CN cyanide. Okay, and you have to attach. यहाँ पे attachment आपको किसके साथ show करनी? Carbon side से, not from the nitrogen side. Not from the nitrogen side. You will attach the alkyl group to the carbon side. So it will give you a cyanide. Okay, your alkyl cyanide plus your KX. So what is the reason? Because this KCN is ionic in nature, so it will dissociate to form K plus and Cn minus. Okay, Cn minus attacks on alkyl halide to form RCN. So examples you can see, this is your ethyl bromide CH3, CH2, Br. Okay, what you are supposed to do? This Cn minus, यहाँ पे आपका nucleophile है, and you know this has a positive center. This bromine is electronegative, so इस पे negative charge है, and this will have the positive charge. So this will attack this carbon, and this bromine will left. So what you are supposed to do? CH3, CH2, and the Cn. आपको attachment किससे show करनी है? Carbon side, so not from the nitrogen side. So that's the A plus KBr. Plus you will get KBr. So this is the reaction of and which type of reaction it is? SN1 or SN2? Bimolecular or unimolecular? Ali?
SN1.
Yes. SN1? SN1 में there is it's a two-step mechanism. But this reaction occurs in a single step. Means first the nucleophile will attack and the living group will left and you will get the product. Okay, and यहाँ पे कोई भी कार्बोकेटाइन का formation नहीं हुआ. So it's not the SN1 Ali. SN1 में क्या था? There will be a formation of carbocation. But here carbocation is not formed. This is your SN2 bimolecular nucleophilic. Okay,
Yeah.
this is your bimolecular. You can see first SN1 में क्या होता था? SN1 it occurs via two-step mechanism. First step क्या होता था? The cleavage of the RX bond. RX bond यहाँ पे cleave हुआ, or you can say the formation of the carbocation. Okay, and after that the nucleophile will attack. But in this case you can see nucleophile पहले attack कर रहा है. Nucleophile first, the nucleophile will attack, and after that this bromine left the group. So this is the SN2 reaction. SN2 reaction, it occurs in a single step. It occurs in a single step. So this is a SN1, not SN2. Okay. So the reaction with ECN is used to increase one carbon atom. Yeah, this is very important. This sentence you can use in the conversion type. Conversion type के questions में आपको ये कर सकते हो. Suppose in some conversions they just give you to same question. Example C. Ethanol. Convert the ethanol to propane nitride. Convert. How you will convert the ethanol to propane nitrile? Now you can see ethanol में there are only two carbon, but propanol में क्या है? There are three carbon, right? So you can react with ECN. ECN को कैसे आप use कर सकते हो? It can be used to increase one carbon, because cyanide में क्या है? There is a one carbon, and if you add one carbon, so it will increase the number of carbon. So here the ethanol से propane nitrile बना रहे हो आप. Okay, so this is the reaction. This is the ethanol, and in the first step में you can add SOCl2. Okay, SOCl2, because आप की first केसीन को treat किससे कराओगे आप? If you do the nucleophilic substitution reaction, means SN2 reaction over here, so you are required. Okay, so this one is needed, RX is needed, alkyl halide is needed, but this is the ethanol. और आपने पहले देखा method of preparation of haloalkanes में, from the alcohols, when you treat it with the thionyl chloride, you will get a alcohol, you will get a alkyl halide. Okay, so in the first step, when you add SOCl2, so what happens? SOCl2, thionyl chloride. So what will be the product over here? Who will tell me? When you treat alcohol, ethanol with SOCl2, thionyl chloride, what will be the product? Anyone? You guys are not revising the chapter. In the starting, we have done the methods of preparation of haloalkanes. और हमने वो वहाँ पे discuss किया था with the phosphorus chloride, with the thionyl chloride. Anyone? No?
Ma'am, we need to replace OH by Cl.
Yes. Simple. Right? So method, it was a method of preparation of alkyl halide from the alcohol. So what you're supposed, it's very easy. When you add thionyl chloride to alcohol, so you have to replace this OH by the chlorine, and you will get this. You will get this. So once you get this ethyl chloride, because you know for the nucleophilic substitution reaction, you are required this alkyl halide आपने चाहिए, right? Alkyl halide. This is your alkyl halide. Okay. After that, you can easily, because this is ethyl chloride, and आपको क्या बनाना? Propyl nitride. Propyl nitride. So this is your, you can do the SN2 reaction over when you add KCN. When you add KCN, तो आप अगर treat कराओगे, this is the substrate ethyl chloride plus you are adding KCN. Okay, so KCN is a nucleophile over here. Cyanide is the nucleophile. So Cn minus K plus, this will dissociate to form K plus and Cn minus. So Cn minus is a nucleophile. So it will attack this carbon. Okay, because between this carbon and chlorine, this is electronegative. So this will have partial negative charge and this will have partial positive charge. And Cn minus electron rich है, तो ये किसके पास attack करेगा? Partial positive charge के पास, right? So this will come, and when the cyanide attacks this carbon, electropositive carbon, so this chlorine will left the group, and you will get 1 2 1 2 carbon, and this 3 carbon, which is C. Okay, so this is your 1 2 3 carbon. You will count this carbon also. So this is a propane nitride. Propane nitride. Clear?
Yes, ma'am.
Yes. Ali, clear? Achha?
Yes, ma'am.
Yeah, so that's how. Oh yeah, so this question is important. This type of question can come in your exam. Okay, so this KCN, basically the basic thing is KCN is used to increase the one carbon atom increase करने के लिए you can use the KCN in the reaction. Next, since KCN is ionic in nature, as I told you, KCN is ionic in nature, it will dissociate to form K plus and Cn minus sign. And Cn minus, because it's electron rich, it will attack the alkyl halide to form RCN. So what is RCN? Alkyl cyanide आप कह सकते हो, और alkyl nitride. Okay. Next, Cn minus act as a nucleophile in which both carbon and nitrogen atom are electron rich. Okay. Now the question is, why the carbon and nitrogen both are electron rich, but the carbon atom attacks the alkyl halide to form RCN. Why? Because carbon and carbon bond is stronger than the carbon and nitrogen bond. Okay, because see, carbon and nitrogen in the cyanide, carbon and nitrogen both are equally electron rich. Both are equally electron rich. But why the C carbon side se attack her, but not from the nitrogen side? Because see, this is your, okay, so this is a carbon, this is a chlorine. What happens when you attach? So the attack of the nucleophile is from the carbon side. Why? Because if it attack from the carbon side, the carbon and carbon bond is more stronger as and more stable as compared to the carbon and nitrogen bond. Nitrogen अगर carbon की तरफ attack करेगा this side से, so it will be less or weaker bond. So that's why the attack in the KCN, because it's ionic compound. अगर यहाँ पे covalent होता just like a AgCN, so the attack will be from the nitrogen side. Then the attack will be from the nitrogen side. But it's a ionic type of bond. The KCN में ionic bond exists करता है. Due to that, this carbon side से attack होगा, because this carbon and carbon bond is more stronger than the carbon and nitrogen. Similarly, if you see the second case, then it will be more clear. Reaction with AgCN. As I told you, silver के साथ अगर cyanide है, तो then there will be attack is from the nitrogen side. Why the attack is from the nitrogen side? Because AgCN has more covalent character than the ionic. It has more covalent character, due to which it does not dissociate into ion. ये dissociate नहीं होंगे ions में. So in AgCN, the carbon atom is covalently bonded to silver. You can see this AgCN, Ag and carbon के बीच में there is a covalent bond. There is a covalent bond. So therefore, only nitrogen bears a lone pair. Okay, only nitrogen has a lone pair, means negatively charged. Negative lone pair is the non-bonded electron, right? So it's a negative charge again. And attacks, so it has a lone pair, so it will attack the R alkyl group of the substrate. Okay, and here it will form, the attack is from the nitrogen side and it will form isocyanide, alkyl isocyanide due to the covalent character. Clear? Yeah. Okay, similar case is these four questions are very, very important. Okay, ये repeated questions हैं. In the previous set questions, either they will give you AgCN or KCN case, or sometimes they will give you AgNO2 or KNO. Okay, in both the cases, you should remember the attack when see, in the NO2 is again the nitro group NO2. So this is the nitro group. N double bond O, and there is an oxygen and उसपे negative charge. So this is again an ambident nucleophile, means the attack is from either from the oxygen side or from the nitrogen side. So when the bond is between the NO2 and the potassium, okay, potassium. So again, the bond will be ionic in nature and it will dissociate to form K plus and NO2 minus, in which NO2 minus has negative charge on oxygen atom. So you have to remember that when in the case of NO2, जब NO2 potassium के साथ bonded है, then the attack will be from the oxygen side, because in this case it is ionic in nature, and the oxygen, the negative charge is on the oxygen, so that's why the attack is from the oxygen side. But the same nitro group is attached to the AgNO2. So in this case, it is a covalent bond. It's a covalent nature. And in this case, the attack is from the nitrogen side. The attack is from the nitrogen side. And in both the cases, you will get the different product. Okay, so now see the reaction. So here, because NOK, NO2 potassium के साथ nitro group है, so it is the ionic in nature and it will dissociate to form K plus and NO2 minus. Okay, one oxygen के साथ double bond and one oxygen के साथ single bond, and there will be a negative charge over it. So the attack is from the oxygen side, this side. So this oxygen side say attack hoga, okay, and there will this is your product. So when the oxygen attacks this R alkyl group, so it will left the group. You will get this RON. Okay, so see the difference. Here the attack is from the oxygen side, but when the reaction is with AgNO2, silver nitrate, your NO2, AgNO2. So what happens in this case? The same thing, just like in the case of AgCN. Okay, this nitrocyanide group when it is attached to the silver, and the nitro group when it is attached to the Ag. So it will be same. The case will be very same. So here the nitrogen के पास क्या है? There is a lone pair. So the lone pair means there is a non-bonding electron. So it will attack from the nitrogen side, and you will get this compound. RN double bond O and AgX. Okay, so you can write on this as AgNO2 is covalent. The oxygen atom does not bear negative charge. It does not bear negative charge. So, and nitrogen is less electronegative than oxygen over here. So, therefore, nitrogen attack the alkyl attack on alkyl halide forming nitroalkane. यहाँ पे nitroalkane बना है. Okay, so just remember when it is silver nitride, NO2 silver nitride, then you will get the attack is from the nitrogen side and you will get a nitroalkane over here. So these four cases are very, very important. Okay, just revise it repeatedly and just know the reason. Because one thing, if it is clear, like if it is the bond of the ambidentate nucleophile is with the potassium. It is ionic in nature, so it will dissociate. And here in the case of KCN, it will attack from the carbon side, and in the case of KNO2, the attack is from the oxygen. Similarly, when it is a AgCN or AgNO2, अगर आपके पास AgCN है and AgNO2, okay, so in both the cases, the attack will be from the nitrogen because nitrogen contains the lone pair, and the attack will be from the lone pair because these bonds are strongly covalent bond. Strongly covalent bond. So that's why the attack is from the nitrogen side, and you will get the iso form. Okay, in AgCN you will get isonitrile, and in this case you will get nitroalkene. Now, if there's any doubt, just please let me know. Ali, Qudsiya, Lubna.
Reaction with AgNO2 and KNO2. Can you show that?
Yeah. Okay, so these are the two cases. AgNO2 and KNO. Okay, so see, let's understand this. KNO2, potassium nitrite. NO2 group hai, so it's a nitrite. Potassium nitrite is ionic in nature. अगर ionic है, तो it will dissociate to form K plus and NO2 minus ion. Okay, and NO2 minus ion means this group. NO1, there is a double bond between the oxygen and one oxygen, and there is a minus charge. And you know what is nucleophile? Nucleophile होता है वो which has a negative charge, which is electron rich. So this oxygen is electron rich. इसके पास negative charge है. Because of the ionic type of nature, this oxygen has a negative charge over it, and due to that, the attack is from the oxygen side. So you can see when the attack, यहाँ से oxygen will attack the R group, and this will left. So this R group and O this side, you will attach the attachment will be from their oxygen side, oxygen and RONO, RONO plus KX will be formed. Clear, Qudsiya?
Yes, ma'am.
Similarly, if it is AgNO2, so because AgNO2 silver के साथ है, so silver, it will form a covalent, bond. Means the bond will be by the sharing of electron. So here the oxygen atom does not bear negative charge. यहाँ पे oxygen will not bear a negative charge. Instead of that, the nitrogen has a lone pair. Okay, and what is lone pair? Lone pair is a electron. Okay, negative charge will be होते हैं because they are nothing. They are non-bonded electron. So this lone pair will attack this R group. Means the attack is from the nitrogen side. Nitrogen is the donor side. Okay, and this will left the group, and you will show R N. Okay, now the nitrogen can only make 3 bonds. Only 3 bonds. इसकी valence 3 होती है, but there are 4 bonds. 1, 2, 3, 4. So that's why यहाँ पे positive charge. There you will write down the positive charge on the nitrogen. So that's the product in these two cases. Clear?
Yes, ma'am.
Okay. Now let's see the next question over here. When 3-methyl butane 2-ol, 3-methyl butane 2-ol is treated with HBr, the following reaction takes place. The following reaction takes place. This is a reaction. ये है 3-1-2-3 methyl 2-butane 2-ol. Okay. When you treat it with HBr, HBr के साथ आप treat करते हो, तो you will get this. You have to write down the mechanism for this reaction. Okay, you have to write down the mechanism for this reaction, and there is a hint given. The secondary carbocation formed in second step rearranges to a more stable tertiary carbocation by a hydride ion shift from the third carbon atom. Yeah, this is quite interesting question. Let's see. You have to write down the mechanism. So let's understand the mechanism step by step. So the reaction was, try to understand and please write down along with me. CH over here, CH3, and here there is a OH group, and यहाँ पे CH3. So this is your 3-methyl butane 2-ol when it is treated with HBr, हाइड्रोजन ब्रोमाइड के साथ आप ट्रीट करते हो, so you will get CH3, C, CH3, CH3, and here CH3, and यहाँ पे bromine. Okay, the question is you have to write on the mechanism. Write on the mechanism for the reaction. Okay, let's write on the mechanism. Try to understand the mechanism. Okay, so first 1, 2, 3, 4. 1, 2, 3, 4. Okay, and on the second carbon there is a OH group, and third पे क्या है methyl. That's the structure of the reactant. Okay, now the reagent is HBr. Now you know very well HBr, it will dissociate to form H plus and Br minus. Br minus. Now what is nucleophile over here? Bromine, and this H plus ion. Now see what happens over here. यहाँ पे कोई भी यहाँ पे nucleophilic substitution reaction नहीं हो रहा. Now see what happens over here. This oxygen has a lone pair. Oxygen के पास क्या है? It has a two lone pairs present. Now what happens? This lone pair will abstract this hydrogen, this H plus ion. This lone pair will abstract this H plus ion, and it will form OH2 plus. OH2 plus. इसके पास क्या हो गया? One hydrogen and oxygen, so which is unstable. Okay, this OH2 bond is unstable. So due to the instability, what happens? यहाँ से ये remove हो जाएगा. It will remove from here. यहाँ से water will be liberated out. Dehydration will occur, and you will यहाँ पे से H2O, this water will be removed. Okay, so minus H2O. Now it has Br minus, right? So what happens next? Next way. So when the water will be removed from here, so there will be a positive charge. There will be a formation of carbocation over here. 1, 2, 3. CH3 as it is. And यहाँ से अगर water remove हो गया from the second carbon, see this. So here there will be a positive charge. There will be a formation of carbocation. There will be a formation of carbocation. Now see the hint. Okay, let's see the hint. The secondary carbocation formed in the step 2 rearranges to a more stable tertiary carbocation, right, by a hydride shift. Now see, so this carbon has 1, 2, 1, 2, and 1, 3 bond, and यहाँ पे क्या एक hydrogen भी होगा. This carbon will have one hydrogen also. Okay. Now see what happens. This is the secondary carbocation. Okay, and you know very well tertiary carbocation is most stable than secondary than primary. Tertiary carbocation सबसे ज़्यादा stable होता है. So if it has some option to attain more stability, by rearrange itself by some shift, so ये क्या करेगा? This will convert to the tertiary. It will try to attain tertiary carbocation. ये tertiary carbocation बनने की कोशिश करेगा to attain more stability, because tertiary carbocation is more stable than the secondary one. So see, this is a plus sign over here. This is a carbocation यहाँ पे, and there is a hydrogen. So this is, suppose this is the first, and this is the second. One position, second position. So what happens over here? This carbocation rearranges itself and it forms a tertiary carbocation. So यहाँ पे क्या होगा? There will be a hydride shift. The hydrogen from the first position, it shifts from the first to the second position. ये क्या होगा? Hydrogen क्या shift हो जाएगा? From the first to the second position. So it will, this is a rearrangement reaction, and this is the, you can write down here on the arrow, it is 1,2 hydride shift. This is known as 1,2 hydride shift. Hydrogen is shifting from the first position to the second position to attain more stability, right? So यहाँ पे hydrogen shift हो गया, and यहाँ पे plus sign आ गया, means positive, right? Now see, this was the secondary carbocation, but this is your tertiary carbocation. Carbocation यहाँ पे, and you can see this is a tertiary carbocation, which is more stable, which is most stable. So tertiary carbocation is most stable. Now tertiary carbocation बन गया, so this bromine, the nucleophile is here. Okay, nucleophile is here. The nucleophile will come and attack this carbon. So this is your SN1 reaction. Nucleophilic, unimolecular nucleophilic substitution reaction over here. यहाँ पे होता है, this bromine will come, which is a nucleophile over here, and it attacks the tertiary carbocation, which is most reactive, and very stable, right? What happens? यहाँ पे होगा reaction, and it will form this CH3 group over here and bromine group. Okay, so that's the whole mechanism. That's the whole mechanism. Clear to everyone? Or if there is any doubts, just please ask me. In any step, if there is any doubt, just please ask. No doubt? Ali,
No.
Qudsi and Lubna?
No, ma'am.
No, ma'am.
Okay, please write it down. So this tertiary is more stable. You can write it. This is more stable. And this is a 1,2 hydration. Hydrogen क्या हो रहा है? From one position to second position, it's being shifted. Done? Yeah, written everyone? Yes or no? Written?
Yes, ma'am. Yes, ma'am.
Okay,
Yes,
so
ma'am.
this is your homework. I'm giving three questions. So you have to write on the mechanism for the reaction. This bromine over here, and this is the CH3. And you are adding water and sodium hydroxide. Sodium hydroxide. So write on the reaction with mechanism. Question number 1, 2 is this. Okay, this is based on the previous question. Okay, you have to show the shift. यहाँ पे shift भी होगा. Sometimes there will be a hydride shift. Sometimes there will be a methyl shift. So just try it in your homework, and if you are unable to solve this, I will discuss it. Second, this is again water डाल रहे हो, aqueous KCl, potassium cyanide. And the third question is this. This is a cyclic structure, cyclobutane, and here is a substitution. Okay. And what is the reagent? Water plus your KOH, potassium hydroxide. potassium hydroxide. So these 3 questions is in homework. Just try it. Okay, just try to just think about it. What should be the mechanism? Okay, so it's based on this. This previous. Okay. So we have already completed the first reaction, which is nucleophilic substitution. Now the second reaction of your haloalkane is elimination reaction. Elimination reaction. So what is elimination? आप eliminate करते हो. In the substitution reaction, you are just replacing one group with the another group. But this is here in the elimination reaction, there will be a no replace. Exact, you have to eliminate. Just eliminate kar dena. Okay, you have to eliminate the group, and instead of that group, there will be no replacement. There will be no replacement. So what is elimination reaction? So elimination reaction is the reaction in which atoms or a group of atoms of substrate are removed from the adjacent carbon in presence of a base to form unsaturated compound. It's called elimination reaction. So what happens over here? Suppose this is your substrate. You have the substrate. Suppose we have an X. These two carbon, one carbon, second carbon. So you have to eliminate one group from this carbon and other group from this carbon. Okay, adjacent carbon में से आपने one group, you have to eliminate them out. And when you eliminate this, when you remove these two groups, what happens? Yeah, ये bond यहाँ shift हो जाएगा, right? So you will get this. You will get carbon-carbon double bond, means the unsaturated type of compound. You will get unsaturated type of compound. Examples or types you can write. There are 3 types of elimination reaction. First one is your dehydrohalogenation. Dehydro. D means removal. Hydro means hydrogen. Halogenation. The removal of hydrogen and one halogen means HX. Dehydrogenation में हम क्या करते हैं? You have to eliminate HX from the substrate. From the substrate, you have to eliminate the HX. Okay, if you are removing the X from the carbon, suppose this is a carbon, this is having X, this is having CH3. And CH2, and this is okay. Now see, if you are doing the dehydrohalogenation कर रहे हो, this is again the type of elimination. So what you are supposed to do, you have to eliminate X from this. X is attached to this carbon, so this is your alpha carbon. Okay, it's a functional group. This functional group, halogen, is attached to this carbon. So this carbon is known as alpha carbon, and the adjacent carbon of the alpha carbon is known as beta carbon. So you are supposed to remove the X halogen from the alpha carbon. आप alpha carbon से X remove करोगे, and the adjacent carbon से you have to remove the P hydrogen. Okay, HX, because we are talking about the dehydrohalogenation, means HX को remove करना. X कहाँ से आप remove करोगे? From the alpha carbon. But B you will remove from the hydrogen, from the beta carbon. Okay, from the beta carbon, you have to remove the hydrogen. So this is your elimination reaction, and this is also known as beta elimination. Beta positions आप hydrogen remove करो. So this is again also known as beta elimination reaction. Okay, dehydrohalogenation, the removal of HX. Clear?
Yes, ma'am.
Second is your dehalogenation. Okay, you have to remove the halogen group. Halogen. Okay, halogenation. So X2 आप remove करते हो. You have to remove the X2. Suppose we have this CH2 X, and again there is one X. So you have to remove one X from the alpha carbon and one X from the beta carbon. Okay, so X2 आपने remove करना in the dehalogenation. So in the dehalogenation, overall X2 is removed. 2 halogen atoms are removed. Third one is your dehydration. Hydration means it means water. Hydration किससे relate होता है? Water. and D कर रहे हो means removal of water. Okay, dehydration is the removal of elimination of water is known as the dehydration. So overall, from the substrate, you have to remove the water molecule. So this is the dehydration elimination reaction. Okay, and in the elimination reaction, because you are removing something, आप कुछ remove कर रहे हो. So for that, for removing something, you are required energy. Okay, so basically heat is required. Generally, heat is required during the elimination reaction. So you will notice in the reaction, in the elimination reaction, आपको यहाँ पे heat का symbol दे रखा होगा. Means in the elimination reaction, heat is required during the reaction. Okay, got it. So I gave you the overview of the elimination reaction. In the next class, I will discuss this in details, like what is dehydrohallucination reaction. We will do some questions. Okay, हम Setzef role क्या होता है, and we will practice many questions. Okay, which type of question can come in your exam? Okay, so for that, elimination reaction. After that, we will discuss the reaction with metals. Okay, metals में basically we will talk about the Grignard reagent, magnesium metal के साथ. Okay, any doubts from today's class? Ali, Qudsiyan, Lubna?
No, ma'am.
No,
Okay,
ma'am.
okay, Qudsiyan.